Hey, what's up everybody? 3D Theory here. Today is August 21st, 2024. It is 2:20 p.m. and this is vlog number 41. So today we have our tiny 3D print farm having finished printing out one full set of plates and latches. The last left latch we had, there was a little black filament on it that got fused in during the printing process, and I decided not to include that in the final production products. It was just something that I did not want to include, but that is looking like a fine print if you ask me. I did notice this here, but again, it's completely flat. Don't know what that is, but other than that, it's looking great. It's going to function as a good product. Real super clean print. Really happy with that. Let's see if there's any Y-axis lubrication needed, and no. But what I am going to do is I'm going to turn off this machine, and I'll tell you why in a moment. But we are burning through these near empty spools of filament, and I am not going to refill it for now. But yesterday, I did have to pull out a jammed piece of filament, and it was a little strange that that happened. And I really don't know what caused it, but I pretty much just used my fingernail to lift that part up, and I picked this thing up and saw that there was a piece of filament in there, and I just grabbed my pliers and I yanked it out, and it was good to go. For those of you who are new here, this is my tiny 3D print farm of 5 Bambu Lab A1 3D printers, the 5th one being right over here, with this one as the AMS Lite combo, as you just saw. And I print out a full set of plates and latches, so you got your left latch, left plate, right plate, and this makes one full set for a product that I'm making. I don't really talk about where these plates and latches attach to, because that's not 3D printed related, and we focus on the 3D printing here on this channel, but I do talk about the production of this because I am my own manufacturer when it comes to these parts. So these are all printed out in PETG gray, and they do a fantastic job on these Bambu Lab A1 3D printers. When they're done, I throw them in their subsequent box. I have it numbered 1, 2, 3, 4, and 5. And likewise, you know where it's coming from 1, 2, 3, 4, and 5. And I did this in the beginning because I was using Creality CR10 SEs, and they would give me frequent issues with printing. I'll have one decent set, and then the next print, I may pull it off the print bed and see there was an issue. So for that reason, I numbered them so that I know where the issue is coming from, just in case I missed it when I was taking them off the print bed and putting them in boxes. And it's just good to stay organized knowing which printer came from where. Someone in the comments did mention to print something out on the Creality CR6 Max over here, and I'm going to come up with an idea, but first we have a couple of projects we need to tie up the loose ends to. I forgot to mention, this Bambu Lab A1 uses up near empty spools of filament, and I don't think I've ever seen so many empty spools in my life. Because of this Bambu Lab A1, it's using up all those empty spools of filament. I don't have that many left. They're pretty much nearly done. So if you look over here, I have 2, 4, 5 near empty spools of filament left. And these near empty spools cannot finish a full plate or latch by themselves. So I put it on this AMS so they can, when one finishes up, it can move to the other to finish one. But nonetheless, as you know, my filament rack, where I keep my filament, usually this stuff sat on top of the filament, it's finished, and I'm in process of receiving it. I'm hoping to receive it pretty soon, but we'll see about that. Nothing like a nice afternoon cup of coffee in a 92.8 degree Fahrenheit 3D printer room with 32% humidity. I'll probably add to that humidity pretty soon. And yeah, and this stuff right here, starting from the Sith throne all the way over to the Vader throne, the Bo-Katan throne, these are thrones for your phone, and this yellow here is a makeshift phone. Kind of shows you how it works. You got green over here and the Stealth TV tray, all available for free on my Makerworld. Links in the description below, so check that out and have fun. By the way, the second project here is this canopy joint, and we're going to be doing that today. We're going to model it out real quick and print it out and fix that thing and call it done, because now we have a couple of things on the list for projects, and I just want to tick them off real quick. And with our filament being low and the amount of products I need for production, pretty much we're almost there. The amount we need, we're reaching that number. So until I get another order, production's gonna slow down a little bit. And for that reason, I'm just gonna shut these off for now. And I'm double checking if any of them need lubrication in the Y guide rail. Nope, these two don't. And what about these guys over here? No, that's looking good. And that too is looking good. Wonderful. So I'm just gonna go ahead and shut these off, and we'll leave them on there for the time being. We're gonna grab this guy, put it in my pocket, as well as my trusty calipers that I went and picked up yesterday. Actually, you know what? Let me put that under my arm and grab my cup of coffee, and I'll see you in the computer. All right, guys, so we're here at the computer. I got Maya opened up, and out here, I have the product right next to me. All right, now out here, we have the product we're gonna be 3D modeling, which is the little joint for the canopy, and our trusty calipers. I'm gonna go ahead and do a rapid 3D modeling session, and I'm going to try to do this as fast as I can without explaining a whole lot to you, and I'm just going to see how fast I can get this done, because I know that people have been asking me, hey, why don't you do it on a Fusion 360 or SolidWorks or CAD software in general? And just to answer that question, I would love to. I definitely need to get on to learning it, but I want to formally ask you guys, what do you think for product development, for product design in a CAD software? What is the best software for that? Would you say it's SolidWorks? Would you say it's Fusion 360? Or would you say it's AutoCAD? Or let me know what you guys think. Which software would be the best? I'm leaning with Fusion 360. I think probably Fusion 360 is the most industry standard, if you will. But nonetheless, let's get started on this. I'm gonna be working in millimeters. So I know my calipers here are in millimeters. What about Maya? Maya, let's see, millimeters. There you have it. So first things first, I'm gonna measure out this exterior part of the cube, which is 34.2 millimeters this way, 34.4 millimeters that way. So I'll just go 34.4, just in case there was some sort of deviation during the molding process. So that's a 34.4, and we know that's the exterior. So now I'm gonna go ahead, let me zoom in the camera actually, so you guys can really see what I'm doing over here. All right guys, now I'm gonna get the measurements of the interior here. That is 25.6, and let's see this way, 25.8. I feel like that's a common thing with this, so we'll just go with 25.8 on the interior. And the way I'm gonna do that is I'm gonna create another cube, 25.8, bring it on down. I'm going to turn on anti-aliasing and ambient occlusion there. I definitely am not working as fast as I could be working, just for the very fact that I'm recording. So let me just grab those and go to bevel, and let's see here. Let me turn off chamfer. Well, this is way too fast. There you have it. And we're about there. And I'd say that's pretty close. Let me try to get a little closer. 0.25. There you go. That is pretty close. Okay. So let me delete that. I'm going to save this measuring cube for whatever reason I need it for. All right. Now we're going to grab this. So I assume the wall thickness in there is probably the same, because I can't really stick calipers down there. I don't know how I would get that measurement, but nonetheless, I'm just going to make it the same thickness as the outer walls over here. And to do that, I will go to the top view, and let's take a look at this. Let me grab my measuring cube, bring this on over to the center, as center as we could find it, and let's bring this down to 5. Well, that's pretty close, but let me see. How about 4? How about 4? 4.5, 4.35, 4.3. It looks like it's at about 4.3, and I can get real accurate with it by creating a center line and another one right across and vertex snapping it to the center. And yeah, that's spot on right there. So I'm just going to get rid of those center lines that I created because I don't need them, don't need excess geometry. And I'm going to go over to my side view. I'm going to vertex snap this to the top and to the top there. And I'm going to go ahead and extrude up. There you go. We are looking good there. Let me grab that measuring cube, bring it on up. And let's modify center pivot. Cool. All right, so pretty much we got this cube part. I want to get that bevel going just to match its design. I don't think it's super important, but we'll capture it anyway. Let's see here. It's about 4 millimeters, so we're gonna go with that. And our measuring cube is almost at 4, but we're gonna actually take it to 4. And let's go ahead and grab these edges. All right, very nice. Go up to the top view, and I'm gonna turn off see-through mode, or wireframe mode rather, and we're just gonna bevel that and bring it on over. Let me see if I can snap this onto the line there so I know where we're at. I did curve snap this time instead of vertex snap. So I snapped this orientation for the measuring cube over to this edge. And I said I wouldn't explain, and I'm explaining. All right, let's see here. Let's bring that over. How about 0.235, 0.232? Let me see where we're at with it. 0.233, and it looks like right on top because it disappeared. Oh yeah, no, we're good. So that's 0.233, perfect. All right, we got the makings of this entire thing. We just gotta bore some holes in here now, one there and one there. And I'm gonna see how big those holes are. It's about 4.2 and 4. Let's see if I can get a 4.2. Yep, so we're gonna call it a 4.2 millimeter hole on both these sides here. All right, let me grab my measuring cube, 4.2. How about I do 4.25? Because I saw some numbers after, and I guess it doesn't really matter, but I'd rather be safe. And I want to know how high from the top the hole starts, and likewise on this side. It looks pretty much like they're level, as there's kind of like a mold line there where the mold separates, so I can kind of see, does it pass through? Yeah, it's all the holes are lining up, so we know that none of them are higher or lower, so that makes our life easier. So let me go ahead and see what the number is there. All right, I'm gonna bring that up to that point. That looks like a 14.2. And how about here? This is a 13.3. That is a pretty big variation there. Oh, here we go, 14.1. How about from the bottom? Let's see, 19.2 and 18.9. I think I'll go from the bottom. So let me grab that, just because there's this little bit of edge up top, and I don't want to lose millimeters there. And the bottom, as you can tell, is just straight. That's good. I mean, it has some ugliness there from the injection molding process, but it's okay. 19.1 and 19.2. So we'll just go with 19.2. Good old coffee. Hey, Hidden Mickey. All right, so 19.2 was the number. Let me go over to my side view, grab this, bring it on down. Actually, one thing I'm noticing here is that the height of this slope is way too much compared to what you find here. Look at that. That is so minimal. I'm not even really gonna measure that, but I'm just gonna kind of eyeball that little bit of a height. And to do that, I'm gonna go in here, grab this, and just bring it on up. And I think that's pretty accurate. If I look at this and what I got in the computer, yeah, that's looking pretty accurate. Although I do wanna go ahead and bevel it later on. I'm just gonna bring it down just a tad bit. You know what? That's pretty accurate. So I'm just gonna leave that. And 19.2 was the number, so let me write that before I forget. 19.2, so I'm gonna grab that, put that through. But I don't wanna use this measuring cube because that's for the hole size. So 19.2 in height. Let me put on see-through mode there. So this is where that's gonna go up to. All right, let me actually create a center line here. Let me turn off the grid because we don't need the grid, but I do wanna create a center line. Okay. There you have it. And just to be sure here, let me make sure this is centered as well. Yeah, that's centered. Okay, very nice. So I can go ahead and just leave that be. And I'm gonna go ahead and grab a cylinder, make it the size it needs to be, but I do want to increase this to 100. So I got a smooth circle, snap rotating that so it's in increments. I do want to make this centered, so I have to create center lines here. Maybe snap this to the center. Okay, perfect. Now I'm just going to make that big enough to reach the edges. I'd say that's where we need to be, 21.3. Very cool. Okay, now that we have that, I'm going to go ahead and duplicate it, bring it on out here. And I just want to make sure that out here, I'm making it in the right orientation. So I know that this is on the left side of the canopy, so I'm going to want to make a hole right here in the front and on the left, as shown here. So front and left. So if my x-axis is, you can see down here, is going this way, that's my front, and I want one going this way, that is left. Okay, now just to double check if everything is lining up, don't need the grid. Got to create a center line. Are you lining up there? Let me go ahead and move this measuring cube. Yeah, that's perfectly lining up there. Very nice. Okay, so I'm gonna go ahead and just elongate this one as well. Before I do that, I did notice a little bit of a dip right here, so the screw head could fit in there. So I'm just gonna go ahead and make that myself. I'm gonna get the correct measurements for that, which is 10.3 millimeters. So let me make another cylinder here, but at 10.3 millimeters, 10.3, and just grab that cylinder, duplicate it, make it bigger, and that's looking good. And likewise, I'm gonna do the same for this here. but I do need a center line this way so I can match it back up. There you go. Is it lined up? Nope. Let's see. Right there. Very nice. I'm going to grab this, duplicate it, and let's see how big I made this one. All right. I'm just going to, you know what, grab this, duplicate that one, and rotate it on over to 0, or 90 rather, and let's bring that to the center, and that is looking good. Let me grab this second measuring cube, put that away, and we can pretty much get started here. And again, this is so shallow that I wonder how shallow I want to make it. And I do want it to be uniform, so I don't want this side being deeper than the other for that reason. I'm going to go ahead and mark a point of how shallow I want it. It's a little too deep, I would say. And we can delete that. I'm going to bring this out here like that so it's lined up with that depth, and I'm just kind of eyeballing it here, and I'm gonna bring it and line it up with this line here, so it's gonna boolean that deep. This I'm gonna go ahead, actually keep it for a second and use it as a way to measure me bringing it over to the center. Did it disappear? Nope, it's right there. All right, that's centered. Let me double check. Yep. Okay, and look at it from the top. I was about to say, did I line that up without even knowing? No, I didn't. Let me line that up there. Very cool. Just to double check. Yep, that's lined up. All right, let's start working this thing. So, all right, so we're gonna grab, let me delete the center line. We're gonna grab this here, then the next one. Actually, let me grab everything, modify, freeze transformations, edit, delete by type, history. And before I forget, since there are holes here, 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 and here, I'm gonna save those cylinders I made to be able to boolean, although this definitely looks like a bigger hole. So for that reason, I probably won't need it. I'll just make another one for that there. Okay, so I'm gonna grab one, then the other, mesh. I'm just gonna rip off the boolean menu here and do a difference. All right, as you can see, we have that there. Likewise for this one, difference. And I'm just going to go ahead and edit, delete by type history. Now we can do the hole itself, difference. Okay. And see how it disappeared on me? That happens because I have history. And sometimes it can just mess with you like that. So what I'm going to do is edit, delete by type history. Now when I do it, it should work, difference. And it didn't work. Oh no. What is going on? Okay, so you know what? I'm going to do it a different way here. Let me go back. And this is what I mean by Booleans being a little finicky. Sometimes things like that will happen. The Boolean function will not work, and you got to find a different way of handling it. And so the way I'm going to do it is I'm going to grab these two, mesh, combine, grab these two, mesh, combine, and I'm just going to do the smaller one first because I think what's happening is these edges that are being plotted onto this new face here going in conflict with all the edges here, and so there's too much to compute. So for that reason, I'm going to start with these first. So I'm going to grab one, then the other, difference. Now I got my holes, which are the most important part. Then I'm going to grab one, edit, delete by type history, grab one, then the other, and difference. It's not working on me. So we got it up to a certain point before. I'm going to separate those and try it again. So I'm going to grab one, then the other, difference, grab one, then the other, difference, grab one, then the other, difference. That one is the one that gives me a problem, but that one doesn't give me a problem. So I found a workaround. So what I'm going to do here is I'm going to first delete the history, edit, delete by type history. And yes, this is kind of a pain to have to do, but it is what it is, and I'm just going to go ahead and do it. So I'm going to go ahead and duplicate this and rotate it 90 degrees. And I'm just going to take the piece that I want. So I'm going to delete everything else, including this. So what do we have left here? I'm going to isolate it real quick so you can see. I have this. So I could even go ahead and even delete that because I don't need it. But I have this piece that has my cutout and it's looking good. But I'm going to put that in a layer for a second. I'm going to go ahead and delete that cylinder because I don't need it, and delete these parts. All right, so let me just go ahead and grab this whole area here, excluding that, and delete it. But we do have that piece that works. So I'm just going to grab these two, mesh, combine, go to display, polygons, custom polygon display, and merge them together. There you have it. So although it didn't work the way we wanted it to with those Booleans, it was just a quick little detour we had to take to make this work. And it worked. Now back to this here. We have some parts here that we need to model out, and I'm just going to go ahead and get the measurements for the outer parts here, and we're at 18.4. Let me start fresh with measuring cubes actually, just in case there's history on there. I just want to make sure everything I'm doing is where it needs to be. So I'm going to create a cube, multiply it by 10 as always, and I think I said 18.2, so we're going to go 18.2 and go up top here. And just to make sure it's correct, I got my hole here and my hole on this side, so I want to go in this direction. Bring that up. Okay, very nice. Then I have a little bit of a gap right there, so I'm going to see how much that is. It's about 3.2 millimeters over. So let me grab another measuring cube, multiply that by 10 and 3.2 millimeters. I'm really excited to see what software you guys are going to recommend. I know that I'm probably making things a lot more difficult for me by doing it in Maya, but this is what I know so far and I've made it work, but nonetheless, I do want to switch over at a certain point. All right, and we're just going to go ahead and see how high this goes. That's at 25.9, so that's at 25.9. I'm just going to grab the height here and do 25.9, but it didn't come out in the way I wanted it to. Is it in depth? 25.9. Yep, it is. Okay, and I'm just going to go ahead and turn my measuring cube. When I start messing with the vertices like that, I won't be able to adjust it this way anymore. So now it's a free adjusting part now. Since we're so close to 26, I'm just going to go ahead and do 26. It's such a small little amount that I imagine it wouldn't matter. Okay, very nice. Now we do have that interior part here, this part. So I'm just going to grab the measurements for that as well. We have 11.45 in the back and 10.8. I think in the back it's 11.5. In the front it's, we'll just call it 11.5 because it looks like it's bent a little bit, this one. So 11.5 is probably what they're aiming for. I'm actually getting 11.6, 11.65. Let me see here. 11.78, 11.7, 11.75. So let's just go 11.8. Let me create a center for this, and this is going to be 11.8. I'm going to make a center for this as well. Modify center pivot. Okay, now we can go ahead and create edge loop. Bring that on over like that, and it looks like they go straight down to the bottom. They do have this little protruding part right here, so I'm going to go ahead and create that. They probably made that for strength purposes, and down on the inside on the corners they have that as well, and they do that probably for strength purposes as well. So I'm just going to go ahead and put that in by eye. I'm going to grab those centers and delete it, and that bottom part too we don't need. And let's just do fill hole for these. There's one thing I realized, that although we got this part from left to right, we didn't get from top to bottom, but it looks to be exactly the same, and also from bottom to where it actually begins. All right, so I want to make sure this width is correct. Let me grab my measuring cube, do 23, because that's what I measured it out to be. Okay, so nope, that is definitely not correct. I want to make sure I get that correct. I just created some center lines, so I know that I'm lined up here. So when I bring it on over to match, it's going to be correct. So let me grab the verts, match it to the measuring cube. All right, so I know that's correct. I know going from here to here is correct. All right, so I'm getting about 3.4. I wonder what it was before. Probably gonna see it when I edit it, but let me grab another measuring cube and do 3.4, 10 here actually, and 3.4 here. All right, where is my measuring cube? There. Now let's go ahead and just bring that over and down, and let's snap it up there and bring it on over. And since I know the width of this is correct, I just have to bring it on up. There you go. Okay, that's looking better. Now that I know that's correct, I'm just gonna go ahead, so I'm just gonna measure it from down here to that corner there. So, all right, it looks to be 10 millimeters. So let me go ahead and make a 10 millimeter cube. I think I'm gonna get rid of this one actually, and do 10 millimeters here. Okay, let me bring that on down. All right, so I remeasured that. It's 9.45. It seems like we got a little bit of skewed measurements here because I got a pretty big gap there. Now I'm kind of curious if I got any incorrect measurements. So that's 36.8. Let me just double check something here. 36.8. Oh yeah. I must have not gotten the height. So for that reason, I'm just gonna go ahead and raise the top here. All right. See, now that's what happens when you're kind of in a rush. All right, so I know that this was 9.45 or 10 millimeters. I got kind of both of them while I was working over here. I'm just gonna go with 9.45 for now. And we had about a 4 millimeter gap, so let me bring that up here. Okay, and let's line that up and bring this to where it needs to be. All right, and if I were to make this 10, it would line up perfectly, but I think we're pretty much where we need to be. Now that we have this pretty much exactly where we need it to be, I do want to quickly go ahead and bevel this, because as you can tell, this thing has beveled corners, or chamfered rather, and every part is a little chamfered so as to not look like a CG edge. So I'm going to go ahead and do that really quick. And grab everything except these holes. I don't need to do these holes. Make sure I got all the edges selected here. And bevel. I'm going to go up to 0.75 and let's do 4 as usual. I think that's looking pretty good. Okay, awesome. Now, this is correct. So it looks like we have one there, which I think I might have gotten confused a little earlier about this part. This nub belonged to this side. So either way, we're looking good here. I'm going to bring this on over this way so that we have one sitting here. And the way I'm going to be able to tell how high up this one is from the bottom here up to that point. So I'm going to go ahead and measure that. Looks to be 13.1 millimeters. Oh, it looks like I've been working on that. Uh-oh. For that reason, I think I confused myself. So let me bring this over here. And this is all part of the process. If you ever kind of get to a point where you created a part that you thought you were working on but weren't, it's as easy as that. So that should be exactly the same measurements that we were working with. The height here is the same. From the corner over is the same. And from the height down is the same. So that's looking good. The only thing I need to look out for now is from this point on over, which is about 13 millimeters. And what do I have here on this cube? 10. Let's do 13. Let me go up top, bring this over here. All right, that's perfectly lined up. And this way, line that up there. Are we right on the dot? We are right on the dot, guys. That is as accurate as it gets. Very nice. Now we have this strange part coming out from here. It's not quite at the edge there. It's just a little bit over. And it comes out quite a bit. So before I go ahead and do that, so let me grab a cube here and multiply this by 10, depth of 30.5, and it looks like, if I'm not mistaken, it's probably at a 45-degree angle. No, it's not, but let me just grab this and duplicate it for now. I just need one, so I'm gonna take this, delete it, modify center pivot. Let me get the center line for this, center line for this. This one feels a little bit arbitrary, but let me bring this back to where it needs to be and match the height. Grab that, bring that down. All right, so I know that the height is correct now. Let me rotate that sideways. In cases like these, where I'm kind of having to guess, I think I'm gonna take a picture and throw it in the computer, and it'll help me model that out and kind of place it where it needs to be. All right, guys, so I went ahead and I imported this image plane so that I can see what I'm working on here. I'm gonna rotate that 90 degrees, bring it on up. I'm gonna try to make this match best as I can so that we got all the accurate details. Okay, I think that's as good as we're gonna get that. I do wanna rotate this just a little bit so that it matches better. Honestly, it's matching as best as I think it'll match, because it is warped. So we'll leave it there. It kind of gives me an idea of where this little diagonal bar is. I'm gonna mess with the lighting a little bit there. There you go. Funny enough, it looks really accurate to where mine is and where it is, but it does look like it needs a little bit of a rotation, ever so slight. Try to line it up again. A little bit of a scale increase. It might be just a tad bigger, but yeah, that's looking pretty close. So I'm gonna go ahead and grab my piece, bring it on over here, rotate it, just so I know that I did the best I could to measure it out correctly. I'm just gonna snap it to this curve here. There you go. Yeah, that's looking good. So I'm happy with that. I'm gonna hide this image plane, throw it in its layer, call it IP for image plane. This is gonna need to be penetrating through. So let me grab that, take entire things through, not to the other side. So when it's ready to Boolean, it's actually through there. Let me look at it from top actually. Oh yeah, That's great. That is looking good. Okay. And since we're pretty much done with that, I do want to get these little support pieces that you can see here. Goes all the way over. And there's just that centerpiece. And all of them on the corners here have those two parts there and that. So I'm going to go ahead and start modeling those out. Since I have a cube here that's conveniently placed there, I'm going to go ahead and just use this to model that little piece out. And it looks like we've got some history on our move tool. So I'm going to reset it there, and everything's going to behave as it should now. Bring this down, and I'm going to want to get this kind of look that it's got going on. So I'm just going to match the look here, and it will serve its functionality as it needs to. Probably going to be about the same height. Yep, it is. I'm just going to go ahead now and grab this, bring it on over this way. Try to match it as best I could. Bring this that away. Just gonna go ahead and grab that edge, bam and bam, this edge now, bevel it. Let's add segments 6, beautiful. Likewise with this one. Okay, maybe I could increase it. Yep, I think I like the way that's looking. That's totally fine. Looks to be the center there, so I'm gonna go ahead and center that out. Let me grab this center line actually, so I can match it up. And it is matched up, that's nice. And it looks to be about 4.4 millimeters thick. Let me grab a measuring cube, apply that by 10. Let's just call it 5 millimeters. You can always go back to 4.4 just to be accurate there. Okay, very nice. That's looking good. Let's see where we're at. We have this part now, which is not all the way through, but I'm going to go ahead and get that measurement there. It's a 3.95. Yeah, so it's a 3.95 thick. Turn that off so I can grab my measuring cube, see where it's at. It's just, I think, a variation because it's so close to 4.4. I'm just going to leave it 4.4. It could be a variation due to the injection molding. And when you look at it, it comes up to the hole, but we don't know where the hole is just yet. So for that reason, I think I'm going to want to create the holes so I know what we're working with here. And as mentioned before, they look to be lining up, but the hole sizes are different. So when I measure this out, we got 5.25. Let's see this way. We could call it 5.2. How about this one? 5. We'll call it 5.2. Let me grab my measuring cube. I'm going to call this 5.2 and go over to parts I want to work on. And now what part was this? Why is this higher up? Okay, it's higher up because I snapped it to that curve, so I just want to make sure we're all on the same plane here, same height rather, and there you go, that's fixed. So I'm going to grab this, and I can work with this now. This is the size of the hole. And how far down is it from where the hole begins to the top there? It's a 7.26. How about this side? 7.35. So let's just call it 7.35. 7.35 from the top down. Very nice. Grab the cylinder, bring that on over. That's too big. Rotate it this way. Find the center point, and the center point this way rather. Also, actually. As long as I can vertex snap that to where it needs to be. 100 here. Now I'm just going to lengthen that out so it can cut a hole in both. Very nice. We don't need these measuring cubes anymore. And just to double check here, let me bring everything back. I'm going to duplicate that, bring that over to the center. That way I can check the height. Yeah, that's exactly where it needs to be. Very nice. All right, so I'm going to grab this, put its pivot in the center of that so then I can duplicate it and rotate it 90 degrees, and it should penetrate that perfectly where we need it. Perfect. I do want to match here, but you know what? Let's actually take out these center lines because we don't really need them. The geometry will be created after we boolean it. Now I do want to make sure this is penetrating. We're almost there, guys. It's taken a little bit longer than I thought it would. I always think things look simple until you get down to the nitty-gritty. Then I realize, oh wait, they're not really that simple. It takes a lot more effort and energy to get it done. Just extruded it out into there so that it's penetrating and that the boolean function knows that it needs to intersect there. Likewise, I'm going to do the same for this, just so that it penetrates there. All right, while we're here, let's just make it happen. So I'm going to rip that Boolean menu off, difference, perfect. And then so I'm going to grab those, difference, Perfect. All right, that's looking good. Let me edit, delete by type history. All right, now we just have these two support parts here, and obviously the ones that we find there. We could do that as we go along. All right, so the hole for this one starts at 5.45. Let me grab this, 5.45. I guarantee you it's probably 6 millimeters. There's variation to that extent, so, but either way, I do want to get this correct. So let me bring this up this way, snap it there, and rotate it until it looks correct. You have it. Looks like 45 on the dot, but it's not. It's actually 45.2. So that's looking good. That's how I know where that hole is going to start. How big is the hole? It's about 5 millimeter hole. So I'm going to grab another cube, multiply that by 10, and it's going to be a 5 millimeter hole. We'll rotate that 45.2 there because I know that that's where it needs to be. Center line here. Line this up where it needs to be. Just needs a center line too so that I can line it up. There you go. That's looking correct. Now let me grab a cylinder, bring it on over, and start bringing this into place. I know again it's 45.2. There you go. And I just want to make sure I'm centered out here with that. Okay, that's ready to be booleaned. And go ahead and this, that, and also these measuring cubes we certainly don't need. Different. Awesome. All right, so we got all those holes booleaned out. I do want to make sure that this is penetrating a little bit so that it can boolean properly. Likewise with this side. Now we can go ahead and create this part here, but I didn't know in the past where it went up to. So I'm just going to bring my cube out to here. I'm going to multiply this by 10, and I know that it's about 4 millimeters thick. There, rotate it wider, because I don't want to mess with the thickness at all, because I know it's around 4 millimeters there. Is that penetrating through on both sides? Yes, it is. Wonderful. All right, and I just want this to go straight back, and because it's at an angle, I'm going to need help by aligning the pivot so that it is the same orientation I want to take it back with. That is looking spot on, but it is in the same kind of area as this, so make sure I line it up to that. Cool, that's looking good. And likewise, we have this interesting kind of support structure here. So I'm going to modify center pivot here, duplicate that, bring that on over. Very cool. And because it's not at an angle, it's a lot easier to work with. Then you're going to just, let me try to line this up more. Very cool. Now the thing with this one is that it's completely lined up top and bottom to the pieces that come out here. So I'm going to do that. I'm going to line that up. However, I can't have it completely lined up because of the Boolean function. So I got to just give me a little bit of room there. We have just this little bored out section that looks like it gets bored out to the same thickness as this part. So with that being said, let me grab my piece here and let's just grab the center line and bevel it, turn chamfer off so I keep my center line and I can kind of line these up to there. Actually go like this. Yeah, that looks pretty lined up. And this one lined up there. Wonderful. Now I'm going to capture this shape here. So I'm going to go ahead and create a new cube here, bring it on over, and I'm just going to eyeball it. So grab this edge there, this edge there, this edge. All right, so let me grab these edges, bevel it, 5 there, these edges, double that, 5. Let me make sure these are just lined up here. Okay, now we have that piece. I'm going to bring that all the way up with that. But remember, we want to keep that center part. We're just kind of boring out here. So I'm going to create edge ring and split, line it up there, likewise up there, and we can go ahead and just cut that part out. We don't need it. And mesh, fill hole. Should have filled both holes there, and it did. And we can just leave that. So we're going to go modify freeze transformations, edit, delete by type history. And let's bring that back. And I'm just going to go ahead. I realized that I have this kind of intersecting. I don't want to intersect that there. So let me grab this, create a little hole there, or not a hole, but rather a little bit of a border. Okay. Because I just want to be Booleaning this part. So let me grab that, edit history, and I think we're ready for a difference. All right. So we're pretty much finished, except we got to just match the bevels on here. So I'm going to mesh combine these and just grab these edges because this is where we're going to need to bevel a little bit. But you know what? I'm going to do these first because these have a pretty strong bevel going on. I keep saying bevel, but it's really a chamfer. Okay, so I'm going to bevel that. That's actually looking pretty accurate. I'm going to just write 6 there. Beautiful. That's what we need. I technically don't need to bevel these here, or chamfer rather. but I will. If I can just grab one each, two edges to contiguous edge, and let's just go ahead, bevel, 0.75. Do we need it that much? Probably not. Yeah, let's just go 0.5. 0.5. All right, cool. Likewise with these, we don't really need to bevel them, but I will, just to kind of not have any of those CG edges anywhere, except for the holes. I have CG edges on the hole. But let me grab these, mesh, bind, grab these contiguous edges, these. Actually, the only edge that shows here are those two, so that's the only ones we're going to work on. Yeah, this is the only edge that's going to show there, and these edges will definitely show. Very nice. Grab those, bring that around. Those two, and bring that around. I'm using contiguous edges to kind of get a full loop there. Now, hopefully nothing's creating a conflict. There's a little bit, because I didn't really get too much of a bevel there, but I think that's fine. I got all those bevels, and I even got them on these edges here, and on all these edges, as you can see. So that's looking good. Let me turn off the wireframe. So yeah, we're almost there. We just got to add those little bits, and yeah, they literally just look like diagonal edges. They're just simple diagonals here. So I'm going to go ahead and rotate this at a 45-degree angle. Do want to make this a little bit thicker. How about I bring it up to this point? I think that's good. Duplicate that, negative 45 here, okay, and more or less that's pretty much the same. Yeah, so I'm going to grab those, mesh, combine, put it in the center, and duplicate that and rotate it over 90 degrees. That should be exactly as the other one. Nice. Oh, and I do want to make sure this is centered out. Mesh, bind, and let's bring it to the center. There you have it. And these are already beveled out, so we're good there. Very nice. This is looking really good. So now it's just a big process of booleaning, modify freeze transformations, edit, delete by type history. So all these are separate objects, and now we're going to go ahead through the process of booleaning everything. So I'm going to go ahead and grab one. I turned off the wireframes, by the way. I'm going to go ahead and grab one and the other. Let me pull out the boolean. I actually want to do these first. So grab one, then the other, union, and that worked like a charm. Beautiful. Edit. I'm going to take this menu off as well, so I can always just delete the history right away. Delete by type history. Let me rip this. Okay. Now that we have that, I'm going to go ahead and union this. That worked like a charm as well. Beautiful. Edit. Oh, we have that here. History. And all that's left are these little pieces. So let's grab that, bring that there, and union. Beautiful. The history. Now I'm saving that. All right, guys. So this is looking really nice. We're at where we want to be. That is pretty much finished being modeled out, and I'm going to go ahead and create some UVs for it. I guess this is what you can call the process of turning this into a solid, because I know that there is a process with that when it comes to CAD softwares. So I did the UVs, modify, freeze transformations, edit, delete by type history. See, I forgot that we have n-gons everywhere. So let me do select, use constraints, next selection, and the whole point of this is to get n-gons and turn them into triangles, because slicer softwares like to use triangles and quads and not n-gon. And this selection tool selects all n-gons on the model and nothing else. I'm going to go ahead and go to mesh and triangulate. So we have a triangulated model now. I'm saving that out. Close and reset. Now we do another automatic UVs, modify freeze transformations, edit, delete by type history, and we're ready to export this out as an OBJ after I name this canopy joint. However, this isn't the angle we need. The joint that broke was on this side. So I'm going to go ahead and edit, duplicate special, open up the options box, reset it. I'm going to have to go in Z here, as you can tell by this blue arrow, where you can find it here is Z. And we're going to scale in Z, -1, duplicate special. And you know what? I can go ahead and delete that. So this is the side that we needed, and we have it now. And hopefully everything lines up, and it's just a mirrored object. And I mean, I wouldn't see why it wouldn't be, but hopefully that's the case. We do have some history again, and the UVs would be flipped. It's just, I'm not going to go ahead and explain that in detail, but I'm going to re-UV it here. Modify freeze transformations, edit, delete by type history, and this thing is ready to go. I'm going to clean up my scene. All right, I'm going to save that again. Now this is ready for an OBJ export. I'll see you guys in Bamboo Studio. All right, guys, so now that I've imported this into Bamboo Studio, we can get it sliced out and ready to print. Now, I don't want a lot of tree supports and use up as little filament as I possibly can. So for that reason, I'm going to go ahead and rotate it -90, and hopefully that'll use up as little tree supports as possible. And I got my PETG standard settings, and again, I like to just increase this to 4 when I want something strong I go to 60% on the infill and I go gyroid when I know that I need something really strong. I don't go 100% infill because at a certain point, I think it really just doesn't matter anymore. Your part just gets heavier, you use a lot more filament, and it just remains about the same strength. I did some research at some certain point, but I always remembered that these settings give you the strongest part in general. And it's not a cookie cutter type of thing, but in general. And what it is gyroid infill 60%, with increased walls to 4. And that's pretty much it. My only big change that I have are these tree supports. I've adjusted these so that the tree supports come off easier, and I talked about it in another video, but I can show it again here if you guys want to take a look at my settings here. And then if I bring this down there, and that's pretty much my tree supports. And I'm going to use PETG, and we'll go from there. I actually want to change this to black. There's no reason for it except that it looks cooler. There you go. All right, guys, I'm going to slice this out. And it looks like it's going to take 2 hours, which isn't bad at all, and about 38 grams of filament. That's great, if you ask me. And I'll see you out in the real world. All right, guys, so I'm going to go ahead and grab my black PETG, and I'm going to be using printer number 5 here with the AMS, and I'm going to load in the file into the SD card, and I'll see you back here. One thing I wanted to mention is that remember that your Bambu Lab A1 really needs to be off when you take out that SD card. And mine was, as you can see here, cold swappable, right where the SD card goes in, which means that you want to make sure that the printer is off before you take out your SD card. All right, so we got that loaded on the SD card. I'm just going to pop that back in. Very nice. Turn on that machine, and that is ready to go. I like to see my preview. So for me to be able to see my preview, I just got to restart it by turning it off in the back there and turning it back on, and it should work now. All right, guys, now that I restarted, let me go ahead and check it out. And we do have our preview, which is great. But before I get started, I want to load the filament. So I'm just going to go ahead and load in this black PETG that I got. Black PETG is essential, I think. Black and gray. All right, let me pop that through to port number 2. Didn't mean to rhyme there, but I did. All right, and we just gotta make sure we have black loaded, which we do. Wonderful. And I'm gonna go ahead and click that. Next. Yep, use black PETG. That's the one we want. And print. All right, guys, I'll see you back here in about 2 hours. When that thing is done, finished printing, we can get it installed on the canopy and call it a day. And it is 4:32 p.m. today, so the release is going to take a little bit longer today, but nonetheless, it's coming. All right, guys, so we have the finished joint piece that we 3D modeled. All right, that actually came out perfectly. Wow, that is a really nice piece, and looks real solid. Very good. All right, I'm really liking the way that's looking. Now, let's actually compare this to the injection molded part. All right, so here's a comparison of the two, and they look pretty identical. How about in height? My eyes played a trick on me. I thought for a second they didn't line up. No, that is pretty spot on. Very, very nice. Oh yeah. Okay, so very nice. So now to address the real issue, which is this broken one over here. I'm gonna go ahead and take out the screw, so we don't need it there. And I'm gonna go ahead and take out this screw, because we don't need it there. And the only way to find out if what I 3D modeled worked is if I go in, put it in, screw it all into place, and see if all the holes lined up. If it did, then we're good to go. All right, let's take this out of there, grab that screw, take this out of there, and lastly, this piece here. So I'm using the needle nose pliers to hold it in place. There you go. Very nice. So this can come straight off the broken one. No clue how it happened, but it did. So that's why I went ahead and did this 3D printed version. And just to double check, everything was correct in terms of placement and whatnot. All right, let's give this a go. Grab my hammer here. All right, that's looking good. That's in the correct place. All right, all these are in the correct places. All right, that's looking pretty good. All right, we got it on there, and it's doing its job perfectly well. It's holding those parts together, and that is awesome. Guys, here's a great example of a practical application of 3D printing and how it can just help with things like this. And really happy with the end result. It's looking great. This canopy is ready for more camping trips. And we've got this project to be working on in upcoming vlogs, which is the Stealth TV tray. But nonetheless, thank you so much for joining me on today's vlog. Until next time, peace, love, and joy.